So next up, we have Katerina Zanos. Katerina is a senior software engineer of machine learning at Meta. She'll talk about building efficient recommender systems, techniques, challenges, and best practices. After this talk, we're going to take a quick coffee break where you can, grab some refreshments, hopefully make some interesting new connections. So let's welcome Katerina. Thank you.
Hello. Can you hear me? Yeah, okay. I'm sorry, I'm the only thing standing between you and the coffee. Just bear with me. I'm also not here to talk about LLMs. I'm here to talk about efficiency, which is not as sexy, but it's important. And as some of you who might be following the news know, our CEO has declared 2023 the year of efficiency. So we do think a lot about efficiency at Meta. So let me figure out how this works. Okay. So I'm Katerina. I'm a machine learning software engineer at Meta. And I want to start by asking you, how many of you have worked on recommender systems here? Okay, a few people. Great. So I've been at Meta for 2 years now. I've worked exclusively on recommender systems. I'm mainly working on Facebook newsfeed and working with many, many other teams to optimize what you see there in case you use Facebook. Before Meta, I was for 5 years at the New York Times, where I also worked at recommender systems. I basically helped build their personalization platform, and I did modeling work. I also did some of the infra work that delivers those recommendations to our users. So you could say that mainly my career has been on recommender systems in the industry. So whether you've worked on recommender systems or not, I think we can all agree that recommender systems are basically an essential part, an integral part of our everyday lives. It's the way basically in how we connect with our friends, with family, how we find inspiration online, how we answer questions, how we shop, how we find what's next to shop with advertising, how we find our next favorite music, songs, how we watch movies, and for some of us, maybe even how we date. So now let me ask you a different question. How many of you, some of you have worked on recommender systems, how many of you have worked on recommender systems or maybe on machine learning models, and you failed to ship that model to production? Okay, some brave people here to admit that they actually. So how many of you have worked on a machine learning system and actually took a lot longer for you than you anticipated to ship it to production, to real users? A few more, okay. I think the reality for most of us who work on machine learning systems actually is that we do, oops, I went too far. Yeah, actually is that we find a lot of blockers as we start, and it takes, if we manage to ship it to production, to real users after experimentation, most of the times it takes a lot longer. And for industry standards, like for the business, that time could actually be prohibitive to make it a product that you actually ship to real users. Maybe they say, actually it's not worth it. Maybe we ship a simpler solution. In fact, a survey by McKinsey found that when ML businesses try to adopt machine learning solutions, only 15 of them succeed in doing so on scale. And another report from VentureBeat found that 87% of machine learning models that are tried in the business fail to make it to production. So actually think a little bit about that. What that means is that most of those machine learning models that we work on never actually get to make it to real users. So today I want to touch on that problem and try to derive from my experience working in mid-sized tech organizations and in large tech organizations, and find those patterns that actually, when detected and when we try to answer those questions in these areas, can help us maximize our chances in making a successful project that could actually reach real users. Before doing so, for those of you who might not be as familiar with recommender systems, let's go back to the basics for just a little bit. So what is a recommender system? Basically, it's comprised of four main parts, four main components. The first one is the retrieval component. We basically retrieve the candidates we want to rank and recommend to our users. Then we have some filtering, maybe on some business domain rule according to our business. Then we have some logic that helps us rank those candidates. And then we might have some post-processing component where we do some additional filtering. Maybe we want to diversify our list of candidates based on the topic they cover. And then as the output, we have the final recommendation list. And in each one of those components, we can actually have one or more machine learning models that power them. And what is that model? Well, it might not be a model at all. It might be just a score, a popularity score that we use and we rank those candidates. Or we might decide that we use a standard approach, such as collaborative filtering, where we use user-to-user, item-to-item, user-to-item recommendations. We might not want to use engagement-based data at all. So we might just go with content-based. We might use just features derived from the content that we're trying to recommend. Or we might decide that we do reinforcement learning. So we deploy maybe a multi-arm bandit or a contextual bandit. And if we have the data and the resources, we might go for a more sophisticated solution, such as deep learning. Spoiled it. But anyway, to train that model, we do need the data. And the data could be user engagement data, could be, again, features, other features that our users provide, could be like the country, the language, like maybe some preferences that they have input in the system, and we know that that's what they like. Or we might, as a company, we might want to train our own embeddings and have our own representation and maybe use that as a feature, as an input to our model. So we have our system, we decide on our model, we have our data, we trained it. The last step in the process is to evaluate it. We can do offline evaluation, or we can, and then once we have verified that it works using some standard metrics, we know our model performs well, let's try it in production. Let's build the overall infra, and then we try it with real users, and we can assess the impact that it has on our users. Okay. So we covered the main components of a recommender system. Now we're all on the same page. So now we can actually talk about the exciting part. How can we do so? How can we build that efficiently? And these are the three main areas that can make or break your success in building a recommender system, or maybe, like more broadly, your machine learning system. This is your system's responsiveness. Second, the speed of development. And thirdly, the cost of your solution. And examining each one of these three areas, trying to answer the right questions, can actually help you maximize your chances to deploying your solution to production. And keep it there, because it can also be undeployed. So let's go examine each one of them and see which these questions are. First of all, systems responsiveness. What do we mean by that? We can refer about how our system responds to things in two different ways. The first one is, in recommender system, how fast should I show fresh content to our users? Can I afford to wait for a day? Can I afford to wait for hours? In the case, for example, when I was working on recommender systems at the New York Times, we couldn't actually recommend a day's old content to our users. It could probably be not relevant the next day, something new might be published, and the recommendation was basically useless at that point. But even in the case of social networks, where one might argue that, it's okay if I see my friend's content the next day, or maybe something that somebody posted, still, it is important for the people who actually create that content that content get distributed as soon as they create it. So identifying that business need in your system and making sure that you cover that, it's important. First of all, if you do identify that you need to surface fresh content right away, you do need to build the underlying infrastructure that will allow you to index that content right away and extract the features that will allow you to recommend it. And then you need to look at the problem in two different ways. First of all, are you starting from scratch? Are you solving a business need from 0 to 1, or are you trying to modify an existing system? Maybe you have a system that already works really well by promoting content that is very popular. And that works really well for your business because guess what? Popular content is probably quality content. If content is bad quality, people are not going to engage with it, and you don't promote it, you don't recommend it, and that's fine. You're safe. But you don't have as good of a distribution as you would like to. So if you do have something in place, maybe the best thing to do instead of working on a new solution is to actually identify the current bias that exists in your system and trying to rectify for that. Another solution, in case you want to deploy something new, is to actually leverage exploitation techniques, such as multi-arm bandits. This would allow for new content to surface and try out, based on a probability. Is that content engaging? I'm trying it out. If it's not, if I try, and I see that people don't engage, maybe I give up. And then, as a last thing, making that decision would also define how you decide between, in the case of recommender systems, offline and online inference. Online inference is expensive computationally, but can actually guarantee that as soon as new content is available, I can actually recommend it. On the other hand, offline batch recommendations are less computationally expensive. We can basically say, okay, we will compute this once or twice a day, but there is an inherent delay that is introduced, and we can't guarantee that we will distribute that content right away as soon as it's available. So this is a trade-off that you need to make, and you need to decide up front. The other part of the responsiveness is what's the actual delay, what's the latency of our system? How many users do I serve? How fast does my system needs to be? And I'm sure many of you know, probably most of you know, that ways to solve around that is to add caching mechanisms. Maybe we add replication. We have a lot of different machines to serve requests. How do we work around that? How much of those machines do we need? In case of cache, how do we invalidate that cache? Again, we go back to how much do we need for the content to get updated. If we have caching mechanisms, do we need to invalidate that cache frequently? We should think about those questions and those solutions, because then it will actually affect our solution later. In the case of Meta, where we have to compute recommendations for billions of people when it comes to the Facebook app, we actually need to optimize every single data request. And so every millisecond essentially counts. So up to the point where we fetch the features, fetch the data, work with cache, respond with the system, we need to make sure that every request is down to the millisecond. So how many optimizations would you need to make your system work for your users? So as a key takeaway, first thing, understand your business needs and your business solution, what you're solving for, what's the scale. Make those decisions, because the responsiveness of your system is going to affect how you build your architecture and also what model you use. So you decided on your solution. You're like, okay, this is my overall architecture. I need that sort of scalability. I will choose that model. Let's go execute on that. I'm sure many of you know that's not always working. That doesn't always work as expected. How can we execute fast? And this touches on three main things. And actually, the last speaker also talked a little bit about that. Well, first of all, is how we position our team for success, both in terms of our team, but also in the broader organization. Secondly, how do we make sure that our solution actually fits in the overall tech ecosystem of our company? And thirdly, how can we catch failure? How can we detect failure and error in our system as soon as possible and correct course? So let me get into those 3 things. First of all, internally, how do you build your team to work to execute on that project? Are you having one engineer who's working on the project? That has actually been my experience both at Meta and at the New York Times for some projects. I had to carry a whole project from beginning to end by myself sometimes. Other times, you can have actually multiple people working on it, in which case you can split the task, you can parallelize, and of course you can execute faster. But how do you decide on the speed of execution? Maybe you can afford the project to be executed in a longer period of time, and you have just 1 or 2 people working on it, and in other cases you need to go faster. So do you have multiple people maybe that could work on the problem? You need to understand what are the different functions that are needed and actually help them, position them in a way that they can work in an optimal and efficient way. And once you have your team and you understand what you need to do, what are your dependencies internally with the organization? Going back to the previous section, we talked about the different components. Mainly the dependencies when you're working on a machine learning system or a recommender system in this case are data dependencies. What are the data that you're going to need to train your model and then to make the recommendations? One great example here that I can think about is that, and I guess this might be applicable to very large organizations, but maybe also to smaller ones, is that at Meta, for example, we train embeddings that represent different types of content. So if you decide that you want to use that embedding to train your model, essentially you are creating a dependency with that team because you will use that piece of data from them, and you need to make sure that that piece of data exists there and will keep being there, and it will exist there when you decide to go to production. Those embeddings usually actually are versioned because they depend on models themselves. So imagine, you start your project, you're like, okay, I have my model, I have the architecture, and I want to use that embedding, that fancy embedding from that other team because it's going to work great. I did some offline analysis and what's going to work great for my solution. You build the data pipeline, you consume that embedding, you train your model, you have your model, it has great offline metrics. You're like, okay, great, I'm going to now do the rest of the work to take it to production. You take it to production, and then as soon as you start your experiment, that team that you took the embedding from, they actually notify you, oh, we're migrating to this new version, so you now need to go back and change to the new version because we're deprecating that embedding in a couple months. And so you now need to go back, change the whole pipeline to consume the new embedding, make sure that this new embedding works with your model, and then make sure that your model is also trained again. So basically you did all this work, and now you have to go back and redo it. How many of you might have that experience from... Okay. So plan in advance, understand your dependencies, understand how they might affect your work down the road, and plan for that. And actually make sure that you develop a relationship with that team in your organization to make sure that that if change will be needed, you allocate time for that as well. And then the third part of this equation here for aligning with other teams externally in the organization is to understand how partner teams in your organizations work on their goals and how their goals could affect your goals. We're all building something to move some metric for our company, based on the value we provide to our users. Every team at Meta and at the Times, they built things to move user value. Maybe it was conversions, maybe it's some other metric, and we all want to succeed. But what if my success actually impacts your success? How is that going to affect then the launch decision down the line when I want to launch something? Am I going to win, or are you going to win? Who is going to have more impact, me or you? Maybe we can actually decide how potentially my goals could conflict your goals, and maybe we can work on them together. Maybe we can both win. But these are things that we need to decide up front, because if you have a solution and then you go and you decide that you want to launch it, then and all of a sudden you decide, you figure out another team doesn't want you to launch it might be too late. So start this conversation early. Bring other people in your organization on board and make them partners instead of competitors. Okay, the other part here is how does my solution fit the overall tech ecosystem of my organization? This can be really simple for some people, or for some other organization can be super painful. It essentially means like what are the kind of changes I need to make in the overall tech stack of my company in order to make my solution work and actually be deployed to real users once I have a working model. Do I have to touch multiple systems? Will I need external support? Will I need somebody to be on board with that? Maybe they don't want me to launch this. Maybe it will create additional overhead and I will have again to negotiate. This is again something that you need to have a conversation up front. Bring those people on board with your project. Make sure that they are okay and they can support you, and you can do this as painlessly as possible. And then lastly, when it comes to speed of development, make sure you iterate. You can actually test your solution. Make sure that you find failure, find error as soon as possible. One way to do this is to, before you even go into development mode, you can do some upfront analysis to verify that your model works and it's promising. And it can do well in online testing. As soon as you have your model, you do again analysis, you verify it works well. And then as soon as you have your model, you go online, you test. But maybe you don't deploy all of the features or all of the different components that you would like. Maybe you do that gradually. And that way you can confirm again that it works well. And you can catch failure and you can fix that as you go. So main takeaway, identify internal and external dependencies in your organization. Make sure you plan for that, even before you go into development mode. Make sure you bring other people on board. Make sure that you are all aligned in how you split the work. And then as you do the work, do test and iterate as much as possible. And then, oh, my slides are a little bit crooked. Anyway, they don't. On the computer, it looked different. Anyway, so last part of the efficiency equation here, cost of deployment. And I'm sure for those of you who are engineers in the room, this is the last thing you think about when you start working on a solution. But it is actually one of the most important ones. So what does my solution cost? Okay, I build it, it works great. I actually can see some user impact, like users are engaging with my solution, with my recommender system. How expensive is it? You know, all of those things that we talked about, resources, CPU, storage space, working hours of the developers that are working on your solution, on that solution. Making the system responsive, like having it actually be, having multiple replicas to be able to handle user requests. All of those things cost money. And of course you can make trade-offs. Remember, like we talked about, for example, offline, online inference. In those cases, it could be that you choose one over the other. So all of those things are going to eventually define the cost of your solution. And then once you have the cost for your solution, then you need to actually measure that against the user value that your system brings. And then you can understand, like, what's the trade-off here? Does actually my solution make sense, actually make sense to be deployed? If I can actually go perhaps opt for a cheaper solution, maybe a less fancier model that could still move user value in the same direction. And once I have that trade-off down, and then I can say, okay, I will deploy that solution. How will that system scale if you have more and more users coming into your product? So, main takeaway, decide on that cost ceiling. This is one of the most difficult things, especially for engineers, to do. And because we don't think in that way. And usually it's really hard to put like the $ against against your system's success. But it is the main thing that if you can at least somehow infer from how your system works, it will actually set the parameters, and it will make your system successful down the road. And it will actually create for a great case for shipping your system for the business. So to summarize, how you build efficient recommender systems. Decide how the recommender system drives user value. This is like one of the things that needs to be defined right away. It will define all these other things. You set an upper limit for that cost of your solution. Make architecture decisions and modeling decisions based on how your system should respond in terms of content delivery and freshness. Then optimize for speed of development by identifying key dependencies and aligning with other teams on priorities, both internally in your team, but also externally. And then assess the cost and resources and choose the best trade-off. Now, all of those things happen before development, right? So again, as you develop, agree on the launch criteria with your org. This is like, again, one of the most important things, and will be based on the cost of your solution and the business value that your solution brings. Test gradually, iterate as often as you can as you develop the system. And at the end, once you launch successfully to production, make sure that you plan for scaling your system so that it can actually stay online and be used by users and keep bringing user value. Thank you. That's all I had. Thank you so much.